everybody, and welcome back. And a warm welcome to our last specialist session for this conference. And we're focusing now on a subject which, of course, challenges all of us, that of embracing emerging technology and its critical role in achieving effective deterrence. And we're certainly struck by the comments made by the General in the last session about how the pace of change is unprecedented. So I'm very pleased to say we are joined by a very expert panel to give us some greater insights into this. They'll be making some opening speeches, and then you'll have an opportunity to ask Q&A via the Slido app, but also we'll have roving microphones in the room as well. So please do give a warm welcome to Professor Angela McLean, who is the UK Government's Chief Scientific Advisor. Air Marshal Johnny Stringer, who's the Deputy Commander for NATO's Allied Air Command at Ramstein, Germany. And last but not least, Mike Paco Benitez, who many of you know. He is now Director of Product from Shield AI. Welcome to you all. So without further ado, I'd like to hand over to Angela to make the first opening statement. Thank you.
Thank you very much indeed. So first of all, thank you very much indeed for the invitation to be here with you. My name's Angela McLean. My role is I'm the Government Chief Scientific Advisor for the United Kingdom. I used to be the Chief Scientific Advisor for the Ministry of Defence, so I did that job from the autumn of 2019 until the spring of 2023 when I took over this job. So really my job now is to make sure that all policy decisions made in the UK government are informed by excellent science advice, relevant science advice, right at their very heart. And it's my job to make sure that that advice is, as I say, relevant, heard, and understood. What I can't always do is make sure that it's acted on. And I think one of the things I would really like to share with you today is our sometimes despair, actually, when we offer over science advice, and for reasons that we think are not particularly good reasons, it is not acted on. But we are civil servants and advisors, not elected politicians, and so we have to accept that. I'm sure many of you in your daily lives hear the phrase strategic advantage through science and technology. It's a source of constant discussion for us in the science advice community in the United Kingdom. And in the office that I run, called the Government Office for Science, we actually have a unit whose job it is to provide what we would call technology and science insights. And what we mean by that is, well, what are we good at as the UK? What are our allies good at? And what's the rest of the world good at? And I wanted to share a couple of insights that have come from that work, which I think are relevant to our discussions today. I think, in particular, the way that works is that we have a list of technologies, we have a list of countries, and we have a list of different ways we might mean good. So good might be how many peer-reviewed publications do you have, how many patents have you issued, how many spin-out companies are there, how much growth funding is there, that sort of thing. And of course, if you do that kind of exercise, the thing that absolutely, well, several things jump out, but I think the one that is most relevant for this audience is the shift of prowess with the rising science and technology prowess in the East. So, in particular, I'll give you a couple of examples. In many, many technologies, China now holds the lead, absolutely, in science and technology patents. In 2021, India overtook the UK in total number of scientific papers, and in that same year, China overtook the US in total number of scientific papers. And I think we shouldn't kid ourselves that that's just because they're writing lots and lots of papers and they're not good papers, and we're the ones who are really great at doing innovative, clever things. That's simply not true anymore. There is superb science and technology coming out from many countries all around the world. And that shifting balance of power is not that we're getting worse, it's that other parts of the world are getting better faster than we are. And of course, fundamentally, that's an incredibly good thing. Think about how the expectation of life and quality of life of our communities improved during our own industrial revolution, and indeed has continued to improve through the application of science and technology across all sorts of arenas. But of course, it does have profound implications for profoundly competitive arenas like defence and security. So continuing to track those kinds of shifts in which country is getting really good at which technology, we believe is a really important exercise as it helps us to decide where to invest our own money and where to look for partners to co-invest with and to collaborate with. Another part of the work that goes on in my office, the Government Office for Science, is horizon scanning to ask questions about, well, which new technologies are coming to change our lives. And of course, we spent a lot of time over the last, well, ever since I've been in post, particularly thinking about how will AI change our lives. Quite a lot of focus on AI safety in this country, and I'm very glad to say now a big growing focus on AI opportunity. And as a scientist myself, one of the things I did want to talk about very briefly was the tremendously exciting opportunities for science in the age of AI. I don't have any slides, but I brought along this very beautiful book produced by the Royal Society about the opportunities, promise, and indeed risks of how is science going to change as AI becomes an ever more powerful tool, an ever more powerful adjunct to the way we imagine and think about things. And I recommend that document to you. You can find it at the Royal Society's website. But I also wanted to share with you an experience I had whilst visiting the Sanger Institute in Cambridge. It's probably not an institute many of you would know because it's the UK's predominant institute for sequencing genomes, storing genome data, and analysing that data. We were there learning about what they do, and we were talking to a research leader there whose research interest is not how can I predict the shape of a protein, because that's an area where there's massive progress been happening recently. I don't know how many of my MOD colleagues will remember the day I sent them an email on the day of the publication of basically the cracking of this problem of the protein folding problem. I sent an email out across all of my senior colleagues in the MOD saying, you should remember this day, because that problem has stood for 50 years and it's been solved, and the outcomes will be astonishing. And most of them wrote back to me saying, well, thank you. I have no idea what you're talking about, but thank you for letting me know. So there are still, of course, lots of other very interesting problems. And this colleague was working on the question not of what is the shape of a protein, but how well will two proteins stick together? Because that's another very, very strong determinant of how they'll function. And he was explaining what he was doing. And I said to him, yes, but aren't you going to have to do 40 years of data collection before you're going to have enough data to drive a really good AI model of what's going on here? Because that's fundamentally what happened with the protein folding problem. So to take a little step back, the problem of protein folding has stood for 50 years. We can determine the shape of a protein, we can read the DNA sequence of a protein, but until a couple of years ago, we could not read the sequence and then say, and without doing the experiment, this is the shape it will fold up into. Because it folds up in this sort of very complicated way, a bit like, can you imagine twisting a piece of string and it would fold in a rather complicated way? But the thing about proteins is they always fold the same way. So what DeepMind did was they took this amazing database of protein sequences and structures that had been collected collaboratively from across the whole world for decades and decades and decades, and they trained a model on it, and it turned out that that kind of model was a particularly successful way of solving this problem. But we don't have that same kind of database for protein-protein interaction. So hence my question to the colleague. And he said the following thing to me, which really changed the way I think about the future. He said, no, Angela, it's not going to take me 40 years to collect the data, because with the model, I know exactly which piece of wet experimentation to do. I know which protein I must make and watch it stick and unstick to another protein in order to make the biggest advances in my model. So with this combination of using an AI model trained on the data I've already got and wet laboratory experimentation, I'm going to be able to make the progress that took 40 years for the protein folding problem, he reckoned in 2 or 3 years for the protein binding problem. And I think that's a really profound thing he was explaining to me, that what we've been used to so far was AI models that were trained on huge databases of existing data, or AI models that were trained because we knew all the rules that mattered, so we could set them off to just generate their own data by playing games in the cloud. But there's this third new way, which is about having an AI model coupled with experimental wet lab data that is your representation of the real world, that is going to, I think, profoundly change the rate at which we make new scientific discoveries, and not only in protein binding. So finally, to come back to deterrence, there were a couple of things said this morning that I thought were, well, there were many things said this morning that I thought were super, super interesting. There were 2 I wanted to refer back to. General Alvin's call for collective agility, I thought was profoundly important. And it seemed to me that his video of a murmuration of starlings was very beautiful, but also very useful, because I think, because I'm a biologist, what we know about starlings is that there isn't an overall plan. Each little starling has a couple of simple rules. We can certainly make a very good simulation of a murmuration of starlings with 2 rules. One says, don't be on the edge, because that's pretty dangerous. And the other says, don't be too close to any of the others, because you mustn't crash into them. And I think that, I'm sure you've all already thought of this, but let us not lose sight of that idea, A, of learning from nature when we can, and B, of a very distributed kind of intelligence as being the way that biology often solves problems. I'm out of time, so I will stop there. Thank you very much.
Fantastic. Thank you so much, Professor McLean, the government's chief scientific advisor, but also a real communications expert, because that is often the challenge in science, and you just showed expertly how it should be done. So thank you very much. Can I hand over now to Johnny Stringer?
Who will inexpertly show how it's not done. What a pleasure. What a pleasure to talk today. I was delighted yesterday, the number of questions which were NATO related. Those who were here 5 years or so ago, I would say there was probably 1 gusting 0. Questions about NATO, and it's a delight to see so many NATO air chiefs here amongst our friends and colleagues as well. I've got 10 minutes or so. I'm going to play very fast and loose with what I've been asked to talk about, because I think there's some other things which one can say about innovation. And we're going to kick off with a bit of subliminal audience participation. So the first mental picture I want you to draw, please, is 6th gen. And then the second one is missile defense and layered defence. And if I remember, I'll come back to both of them. My apologies as well for the non-Brits. There may be a couple of UK cultural references that come up in the in my pitch. So badger anybody in light blue afterwards to explain who Sergeant Wilson is and the Thunderbirds. One other thing, if I may, because I'm very conscious that, you know, any UK officer talking at the moment on the launch of a defence review is always going to be seen as putting subliminal messages into things. So genuinely, I'm not going to do that at all. And I'll just put a few bald facts out. What I would ask to friends and colleagues in the media is, let's just ensure that between now and the launch, the findings of the review, that we have a quality in the discussion that was there in the 60s and the 70s and the 80s, but I think has been lost in the last 20 years or so. And I'll come back to that. Final. I did ask, by the way, for some North Korean. I want rattles, I want applause, I want tears, I want a whole lot. So as I run my countdown clock down here, I'll offer one other thought. One of the beauties of coming late in the conference is you generally have time to think on the themes, the insights, Greg Bagwell's footwear that came up on day 1. The downside is a lot of these sandwiches are eaten. So in that spirit, let me try and build a bit on what CSAF and Kaz spoke about earlier as a backdrop. We've had a lazy 3 decades. We won the Cold War, we didn't have to think too much about stuff, and that's the first long shadow over our air and space power. The second, slightly shorter shadow is 2 decades or so of counterinsurgency operations. So one thing I would say in this audience is we've hitched our star at times correctly to other people. But we need to make sure that in the air and space domains, we're hitching our star or our wagon or whatever it may be to the importance of the 2 domains. And without going into massive detail, you heard comment yesterday on NATO's family of plans, which genuinely is the best plans framework we've had in years for how we deal with Russia. I'll put a few things out there right now. There's kind of 5 of them. No matter which plan we may have to activate, we're going to have to do some things. One is integrated air and missile defense to protect all of NATO's nations. We're going to have to deal with the anti-access area denial bubbles. By the way, a great discussion to be had over whether we have a philosophy in air power. And again, if I don't run the clock down, I'll come back to it. The third is how we deal with the Russian surface and subsurface. The fourth is we have to keep strategic lines of communication open. And the fifth is we have to deal with the long-range aviation threat in a way we've not had to deal with before. All 5 of those rely on air and space. So a phrase or term I hate is enabling. It's passive, it's soft, wrong. Air and space power is foundational for how NATO will need, God forbid, to fight and prevail. It is not optional and it's not passive. Our adversaries have learnt from our way in warfare. If I'm being really blunt, and I'll put a question mark in on the 3rd bullet, it's not actually, it's a tick. Our evolution is in lag. We have polished second offset strategy. And some folk here would have probably heard me say it before. I think one of the things the US did, though it was never couched as such, is it got its 5 T's absolutely right from the very late 60s and through the 70s, by which I mean it thought about technology, its overall thinking was right, it translated it to tactics, that then came into training. No surprise that this is the foundational decade of red flag, something which we in NATO are seeking to replicate this year with Ramstein flag. And the 5th T is it spoke to a theory of victory. For innovation, I really worry, and I realise I'm off the pace, I'm an idiot who lives in the Rhineland, though by the way, great to see 2 history graduates speaking to you in 24 hours, CSO and myself. But if I come back to looking at the landscape I saw in the UK 2 years ago, having done a year with a tech startup, we're talking the right things, but our mindset has not moved on. And if we're really serious about this, we should not be putting on the constructs in a commercial and a process way for a £1 billion contract for something that's £1 million. So I'm not sure we have generated what I've said there as a culture, but it's more than culture, it's the processes that go with it. You've heard from a number of speakers about the reinvestment in equipment. That is vital, but let's make sure we've reinvested in the conceptual component as well. There is no point spending 3% of GDP badly when you can spend 2.5% better. And what we have to do, and this is really the theme here, I'm not going to talk, and I'm not talking now, about what I would call performative innovation. I'll put a hoodie on, some sneakers, point to the coffee machine and the bean bags, and I'm really cool with the kids. What I'm actually talking about is the things we can do and are doing in NATO. So to answer Greg's challenge from yesterday on the how, what I want to do is focus on just 2 of the 5 priorities that Rich highlighted as my commanders. So I'll talk about IAMD. So right, back to the first subliminal word association, football. If we were talking about layered air defence, how many of you had hemispheres in your mind? One of them V-SHORAD, one medium, one long, all are at a defended point. Wrong. We just have to move on from that. And there's a really interesting back to the future here. NATO realised this in the 1950s, commissioned a series of very important and insightful reports. I would love to declassify the 28-page that was in my inbox last week, because it shows how many of these themes are consistent. First British cultural reference. Sergeant Wilson is the fantastic NCO in Dad's Army. Just about every comment Sergeant Wilson offers begins with, "Would you mind awfully?" And our approach to IAMD has been Sergeant Wilson. We talk about air policing. It has a comfortable constabulary feel about it. We need to be much more hard-nosed. We need to go back to the sense that what we're actually talking about is air defence, how we organise ourselves to do that. To my final bullet, this is everything from how we sense, understand, command and control to the effectors that are required. It is a genuinely multi-domain game, this one. Mentioned earlier high-low, and I know high-low is a good shorthand. Actually, there are various levels of stratification here as to what we should be buying and funding and where we position it. And for obvious reasons, I won't go into too much detail, but I would say that we are looking at IAMD as an overall mission in Aircom and taking it back to first principles. Let me riff a little bit on bullet 3. Lots of talk on mass. Absolutely right. There is a wonderful documentary from World War II somewhere on YouTube of the 24-hour Wellington, by which 24 hours to build a Wellington medium bomber. How long to build an F-35, or a Gripen E, or a Rafale, or a Typhoon? So we've got to think about what mass looks like and how we regenerate it. So that's the sort of physical bit. Also, cleverness, ingenuity, and a bit of cunning in how we use what we've got. So, for example, very clever mission planning, layering of systems means I send 2 very high-end and expensive things. I don't send 10. So I've just 5-fold increased my effective mass. Back to conceptual reinvention rather than just chasing pound signs. And the bit which people probably don't want to hear, but we've got to be honest about it, is air defence done properly over the decades has relied on the offensive as well as the defensive. Sitting there thinking you're going to shoot every arrow that comes with you is frankly for the birds, murmuring or not. And at the enterprise level, this means interdicting supply chains, factories, logistics, well before things actually get fired. So left of launch has many aspects to it. Then the second bit is innovation in Air C2. I underlined the first bit because those are just the classic bromides that people at conferences like this throw out. You'd agree with all of it, but it means nothing. The bits underneath it are important. So what are we doing right now? And we've already started testing some of this. Take the classic 2 levels of centralized command, decentralized execution, and unpack the first one into 2 strands. So absolutely centralized command. You heard it from the Norwegian Air Chief yesterday. This is theatre level stuff. This is not penny packeting, private air forces or whatever. Centralized command, theatre-wise, because nothing crunches time, speed and distance like air and space power. Digitization. How many chiefs here genuinely think you're first followers? And how many of you in reality, like NATO, in too many areas are last followers? And I put a small challenge out as I really run the clock into the red, which is, are we making digital decisions on operational need or an accreditation framework? What we also need to do, touched on yesterday, is increase our operating locations because that absolutely speaks to capacity and survivability. It's recasting the model against those 3 lines that I said, and very much looking in the multi-domain ops concept. And one of the things I probably should have made on IAMD, the second cultural reference, the Thunderbirds, back to mass in all of these things, and frankly all of our 5 priorities, and they apply to air and space, is Thunderbird 2. Thunderbird 2 was the one that came up on racks, and then you put the specific payload into the aircraft and off it went. I am at heart a truckie. So we need a Thunderbird 2 mindset here. We need to buy things that you can repurpose. And by the way, we need to do things where we are buying in the hundreds and thousands because some of the bullets I've put up there allow you to do that. And my final thought, and why I put the unclassified bottom right picture up, that was, and it will be different now, the Ukrainian UAV Orbat. Those things I've mentioned at the top, if you really think your way through them, allow any air force with any budget to look fundamentally different from our perception of it and to deal with things in a fundamentally different way. Why did I ask you to think about 6th Gen? I won't ask for a show of hands, but I bet most of you thought about a platform. What we should be thinking about is 6th generation air and space warfare and what that requires. And some of it is very cheap, and a lot of it ought to be very different. Thanks very much.
Thank you very much.
Sorry.
Well, I don't have a hoodie and I don't have sneakers, but my rebellion up here is I'm not wearing a tie. Okay, I want to talk to you for a few minutes. I'm going to cut it short so we can get to the questions. So hopefully, and actually, if you can put the thing up there for the questions, I would like to make sure that we have a lot of time for questions. First of all, I am the last person on the last panel of the last day. So what more can I say that hasn't been said already? I'll come up with a few things. First of all, I can't believe that no one at any point in this conference pointed to the picture that has some kind of F-35 pilot on the left and some kind of android on the right. No one at all had made fun of that. Hopefully we'll talk about man and machine teaming in our discussion today, so I want to get to that. But I'm not going to do is, as a technology person from a technology company at a technology panel, you think I'm going to talk about technology. I'm here to tell you it's not going to solve your problem, okay? But what I will say is that is going to be part of every solution. It's very, very important that everyone in this room understands it. I think about the 3 T's. You have the technology, you have the tactics, and you have the training. You have to have all 3. For a modern Air Force, if you're only doing 2 of those 3, you are failing. You have to think about all 3 in concert, connected at all times. The other part of that, and this is the new level of thinking that we're getting to with that funny picture on the screen, is we think about hardware, we think about software, and now we're thinking about wetware. And so wetware is where the human comes into that, the human cognition. How does the human interact with this machine to do what we're trying to do? So previously we talked about hardware and software interactions, hardware and wetware interactions, and now the new generation we're thinking about software-wetware interactions. And so collectively we have to be thinking about all 3 as we move forward for building systems for defense. And I can't talk about, I have to talk about deterrence because it's on the panel. What more can I say about deterrence except that there were some really good pictures up here and some funny pictures of animals, and I will, from the cast. So one thing I will say is the squirrel on the left, he was not deterred because he actually did try and attack the pole. And so we do want to make sure is he doesn't even try to attack. So he was deterred by that spring. And on the right, you have the cat. And the cat was not deterred from attacking because the water bottle kept attacking him back, right? So that was the counter-strike. And so what I'll say to that is that part of technology and deterrence is that you have to be able to have credibility and you have to show it in the manner that it's going to be used. So you can say those are animals, they don't understand what they're doing. The cat's probably smarter than the squirrel, but if that cat had seen that water bottle and see how much water it has, its magazine depth, it's seen its range and its power and its effectiveness or max effective range of the water, it would have a different calculus. It probably wouldn't have gotten that close, right? So the way that we can preemptively show these things and show that and build that deterrence by being prepared to deter an attack was what General Saltzman said yesterday. It was a great speech, by the way. So on that note, the other thing that when I stand here in front of all the air chiefs here, I think about deterrence, integrated deterrence, and as an American, I've got the funny U.S. accent standing up here. We think about it as through peace through strength, as kind of enduring, the politics aside, peace through strength. And one of the things that come to mind is what is the enduring strength from the United States? I'll tell you, it's not technology, it's not the nuclear weapons, it's not the $800 billion budget, it's you guys. And that's the 4th T. So we have technology, tactics, training, and teamwork. So we have to do everything as a team. And I'll end that with the last thing I want to say, which is in the past we talk about working together with integration. We want to work alongside our partners and allies. That's not good enough anymore. And that was alluded to a little bit yesterday. Integration, flying in the same airspace, being on the same radio, being in your altitude block, doesn't matter. That's not going to win the next war. In fact, that's probably going to lose the next war. Interoperability is the key word that everyone should be shooting for as a threshold objective, which is how do we actually work together collectively as a coalition, combine our resources to achieve a common objective. What we really want to get to, and software I think opens the door for this, is interchangeability. That is the next level of interoperability. I'll give you two hardware examples, just because software is a little abstract still. So in World War II, one of the big challenges that the Allied forces had was they had all these, they were building all these bombs, different types, different shapes, different sizes. But the problem was they couldn't put them on all the different aircraft because bombs were coming from different factories, airplanes were coming from different factories. And so after World War II, when NATO was established in 1949, one of the first things NATO did was establish a standard for interchangeability of weapons on aircraft. And so today, if you in this room have an Air Force that has an airplane that drops a bomb off of it, it either has a 14-inch lug spacing or a 30-inch lug spacing. And that dates all the way back to the lessons learned about interchangeability from World War II. More recently, and this will talk a little bit multi-domain, the F-35. Those that fly the F-35 in the room, you know it has a gun. Opinions aside of how effective the gun may or may not be with its ammo, but it uses a 25 millimeter Gatling gun. And that bullet, it's 25 millimeters by 137 millimeters. And the reason why it's 137 millimeters has nothing to do with making sure we designed the best bullet for the F-35. It had everything to do with making sure we had interoperability and interchangeability, multi-domain. And so that bullet that goes in the F-35 goes in the 25 millimeter defense weapons on Navy ships across the coalition. It's the same bullet that goes in the 25 millimeter guns on the Army's infantry fighting vehicles that many of your services use. And so I'll use that as your analogy for software. Human, machine, interface, teaming, interoperability, interchangeability. We talked about CCAs, and I'm really looking forward to your questions to talk more about software, autonomy, robotics, and unmanned systems. But I want to set all that out to frame this discussion, and I'm looking forward to your questions. Thanks.
Thank you very much. So without further ado, I'd like to put this question to you, Mike. We've spoken about the need to be collaborative in innovation. Is it time to stop building sovereign systems that are interoperable and to start consider collaborative development of common systems?
Yes. So from industry, none of the industries that we have in any of the nations, whether it be the UK, the US, everyone is always looking to partner, right? So there's partners and allies. We talk about the air services. There's partners and allies in industries, and that has to be trans-regional, international, and anyone that's in defense industry would tell you they're always looking for positioning and partnerships of how people can work together and create synergistic outcomes, not only from a business case, but from a capability base to solve people's problems, namely the people in the room. So absolutely. Is there a good conduit to do that? I'd say it's challenging. I think it's getting better. If you are and it's a balance, right? Because every nation in this room, I think in the last 10 years, has realized that if we don't do things ourselves, that skill will atrophy in our industrial base, and we're not going to get it back. Reference F-35 and then 6th Gen. Like how many 5th Gen programs are there? There's the coalition of kind of one. I think everyone's realizing if we don't build an aircraft in the next 50 years, no one in our country will know how to build an aircraft. And so you get these incentivized FCAS, NGAD, GCAP, et cetera. So there has to be a way to do it. I have seen promises, but I don't see an actual framework of working together.
Okay, thank you, Joyce.
So very quickly on that, the 5 priorities mentioned earlier, they actually rest in an integrated by design. The clue is in the title, campaign plan from AirCom, and it's mirrored in USAFE as well. If I took one strand, agile combat employment, because it was mentioned yesterday, we've just released internally our ops design, building on our ConOps for it, because agile combat employment in Sweden or Finland looks different than it does in Italy, France, Germany, or the UK. But there are some fundamental principles that apply. Part of that is ourselves getting back into the game of stuff like aircraft cross-servicing, which we were really good at, and then we kind of just let it go. And NATO is pretty good at standardization. It has the standardization agreements, the STANAGs that Mike was talking about. But if we're honest, some of those were kind of more honoured in the breach over the last couple of decades because we didn't have to worry about it. That first long shadow, we now need to worry about it. And we're very much getting back into that place.
Okay, thank you. Angela, a question for you, and one which I think a lot of people have really been thinking about recently, is artificial general intelligence a juvenile science fiction delusion or a serious risk and opportunity? And what do you judge to be the subjective probability of its arrival in under 5 years? what does it have to be before we plan for it?
Thank you very much. Well, first of all, it's a buzzword, and my guess is that unless it is very demonstrably with us in 5 to 7 years' time, for the rest of my life we will argue about whether or not we have it, in a way that's sort of quite boring, actually. And I think the interesting question is, I think the really interesting question is, how can we do our jobs better, your incredibly important jobs, various other jobs that government does about making lives better for citizens. How can we do those jobs better using the AI that we've got today and with clear plans for how we're going to use the AI that we know is coming tomorrow? And actually we know what we have to do, because the thing we have to do is sort out the data we've already got. How do I know that? Well, because I've had working life in data analysis and modelling, and the rule of thumb always was it's 80% effort on sorting out the data, and then the algorithms are actually reasonably straightforward. And I don't think that's going to change. And the second way I know that is from the example here in the UK government. If you look at the bit of the UK government that is going absolutely great guns with the new kinds of generative AI, the stuff that's been in all the newspapers the last year, it's the Department for Work and Pensions. Why? Because they put a massive investment in sorting their data out. They figured out, actually, we're a data organisation. We have two things. We have a massive, great rule book about how we persuade people, help people get back into work, and what state aid is, what state help is available for certain individuals. We have that, and then we have a massive data about people. So they sorted their data out. So when generative AI came along about 2 years ago, they were able to start building really, really useful products. The first product they've built, this one's already rolled out. Do you know what it does? It reads letters that come from people, which of course will arrive in all kinds of formats, typewritten, emailed, some of them even handwritten. They're always under immense pressure to get back to people. They've written a generative AI program that will read any of those letters and find the people that they must get to in the next 2 days, because something terrible is going to happen. They have other things they do, but I'm not entirely sure they're public. So, but there are some there are some things they do that are sort of rather akin to what I was talking about with the model and the experimentation going hand in hand. So things about service delivery for individuals, where what you do is you use a model to tell you, today, these are the 3 pieces of information you must solicit from this individual so that you can, A, help them figure out what they need to be doing to get back into work, and B, tell them what they might be entitled to. Back to the real question, am I going to take a punt on that? No, I'm not, because it's such a poorly defined term. It really is a poorly defined term. We did a lot of work on this a year ago, exactly this question, and we ended up thinking, in fact, the definition is so contested that the debate ends up not being terribly exciting. You end up with a long debate about, well, is this AGI or not? And in fact, there are a whole load of super interesting questions. I've talked about opportunity. There are a matching set about safety that you can have without falling into, I think, the fallacy, and I am an academic, of only talking about definitions.
Okay, thank you. On that, staying with the AI point, though, we hear that AI is central to the future of air power to achieve effective deterrence. Why is the UK so slow to invest scaling AI as China and Russia are? Johnny, have you got a view on that?
Yeah, just before I do, could one of the wonderful air staff team make sure my wife can get in? Because I didn't go to the front door and say Lisa Stringer is pitching up. So if you could do that, that would be brilliant. Right, so AI. I would contest that premise, actually. The UK, depending which metric you take, is kind of in the top 3, top 5 on AI development. So in terms of the fundamentals, so it's a pretty good backdrop. We were discussing, by the way, over breakfast this morning, even allowing for that statement, when one looks globally within all of the nations that are here, it's not a massive pool of talent that we're fishing in. That is an absolute truism, and we need to build that. And I speak as a father of a computer hardware and software engineering graduate. He chose the wrong path, but never mind. But the point being is, we do have the resource, and I think the bedrock, and Angela will know this far better than me, to draw on. what's holding us back? So 2 years ago, I spoke here and I said that on AI, we still, in the public discussion on it, feel about it rather than think about it. And I think it's beholden on all of us. The bit I didn't say, by the way, when I mentioned on the engagement, media, sophistication and debate, that doesn't happen unless we're in that debate. So we have to talk about it. By the way, autonomy in weapons goes back to the first infrared Sidewinder, or even probably earlier. So we've been here for decades. By the way, what happens with the 155 unguided shell when it leaves the barrel? So we're just not having a richness and a history in the discussion and the sense of what is essential here and what we therefore have to apply as air and space forces. Nations will have different perspectives on where the human needs to be in, on, whatever, on the loop, and that's absolutely right, because societal and cultural things are a key part of this discussion. But I still look on 2 years from chatting here and go, I'm really not sure we've moved that discussion on in public, and it's beholden on us to do it, because if we don't, we're going to end up facing adversaries who not only don't operate to the same moral compass we do, but they are absolutely progressing stuff here. To the questioner's point, we can't afford to be in that place.
Dame Angela, I just want to get your perspective on this. You talked about the crucial importance of data, which underpins everything. So in some respects, do you think maybe China and Russia are accelerating more quickly into scaling AI, but do they have the data, do you believe, the deep data wells, accurate data wells to underpin that?
I don't know about Russian data. I certainly know that in scientific circles, China is extremely fast and thoughtful about the data that it collects and the way it stores it so lots of people can use it. And I go one step lower even before the data, which is to be very, very clear, what is the question? And I think that is something that it just does require time to stop and think about. What is the problem you're trying to solve here? Because I think too often people in many walks of life, Mike, this is probably your lived experience. Well, I've been very interested to hear about your lived experience. They say, oh, I've got this kind of problem, but I'm sure AI will sort it. That won't do. You need to be more specific than that with actually what is the problem here. And if you can, and then what you need is really good, rich conversations with people who understand the creating of AI tools, who can understand your words. And I mean, you might forget, but military words, you have a very specialist language. I mean, I had actually forgotten sitting here today. I'm thinking, oh yeah, that's right. They talk in this really weird code. So you need relationships with people who can understand your language and turn that into a question that AI tools can address, and then talk to you about, well, what's the data you have, what's the data that you don't have, but you might have access to a proxy. I'm very, if I may, inclined to pass this over to
So
Mike.
what questions should we be asking, Mike?
Well, what do you want it to do? What are you trying to do with it? Like the data, and honestly, like some AI doesn't even need data. Like that's kind of the thing that no one really talks about. There are certain types of applications where you use AI as a tool to do something that you need the data. Two examples come to mind. One of them is computer vision. So if you want to do like scene recognition, that kind of thing, you're going to need to use a type of AI either called supervised learning or unsupervised learning, and there's a hybrid one where you get lots of data of this is what a water bottle looks like, here's the different angles, here's the different sizes, and it starts mapping out those attributes. You need the data for that. The other type is to create those inferences that Angela mentioned. Now imagine if you had a large language model, which already exists, and then you took something like everything Putin ever said over the past 30 years. You could actually feed that into what's called a RAG on the side, and you could actually query the model as if it were Putin and create inferences of everything he's ever said. You'd need data for that, and you would absolutely want to have clean catalog data of what he's actually said, not just what people have said that he said. But for the, applications of autonomy, ATR, ATD, that kind of stuff, for your image recognition on sensors, you actually don't need a whole lot of data. We actually do synthetic data generation. We use reinforcement learning as one of the techniques. We actually create these training leagues of agents, and then we call it league play. They basically fight each other, and then we do it hundreds of thousands of times. to create these inferences and learning, but we create our own data to do that.
So there's a question here which is probably at the top. Looking back at 2022, then how could we have better used technology to deter the Russian invasion of Ukraine?
Ooh, great question. So 2 things on that. I would say that when the invasion started, and we actually didn't talk about this at all yesterday, which is surprising. I think you could characterize the invasion as a dislocation strategy. He wanted to seize the capital within 10 days. That failed. I think he pivoted to an annihilation campaign for about 72 hours, and then it devolved into an attrition campaign, right? So the real question is, how did we deter that dislocation campaign? Why did he think he could take the country over in 10 days? Which is a whole different discussion, and there are experts in this room way smarter on that to answer that than I am. But the other question is, and General Seltz and I were talking last night, is it an undeterrable event? So we just spent a generation in the Middle East fighting irrational people. Like, you cannot rationalize with them, and there's nothing you're going to do is going to stop like a 9/11, right? They're just going to find a different way. So I'm not saying that those two are the same, but I think there's some parallels to draw from that. I think to say that Putin invaded and that's a failure of deterrence, I think it's a mental shortcut that everyone in this room is too smart to fall for. I think it warrants a very, very difficult conversation.
So can technology help against irrational actors? Johnny?
Well, I mean, on a very simple level, yes. The point I'd make, if I can, Suzanne, just sort of bridging from that question. I was struck yesterday by General Saltzman's comment, which is absolutely on the money. Don't configure your forces to deter. Configure your forces to win, because that's how you deter. And as we roll into Fairford, ask ourselves, have we created a few airshow air forces? Something does 9G in front of the punters, something you can look at in the static park, but we haven't addressed all the other lines of development. And that almost comes back to the first pitch yesterday on where you put your money to ensure that your credibility and your capability and your ability to win is underwriting your deterrence. The second bit I'd reflect on yesterday, directly related to the question, it's a shame because Jim only had the few minutes he did. The graph on oil and gas revenues, anybody have a look at what happened between 2014 and 2015? It went up. So after the annexation of Crimea, we had an opportunity to demonstrate from the economic and political levers that we were serious about what was going on under Putin 2 or 3.0, and we gassed it. So therefore, having a deterrence discussion, could we have done this, that, or the other in 2022? I hate to say it, we'd set the conditions beforehand. And those conditions were set in places other than just Ukraine.
Okay, thank you. I'm going to open the floor now because I know we have a question over from the media team, the media representatives here. If you could bring down the microphone, thank you very much.
Hi, Mark Ronning from Defense and Aerospace. Great discussion. And I would ask, I guess, this question of Air Marshal Stringer. You talked about the theory of victory, right? What does a cogent theory of victory look like at a time when we are, all of us, in financial binds? The U.S. Air Force is considering next generation air dominance, in part by trying to calculate, I think as General Alvin has talked, like what's the best investment of that money? Is this program the best way to move the needle? Justin Bronk yesterday talking about, okay, do we need to do global combat air program? Is that the best use of resources? What does that theory of victory need to look like to then guide your investment to build the forces that are those winning forces that go beyond an air show ramp, great air show ramp, even though that's lovely, and who doesn't like an air show?
In less than 12 words? Right.
You can take as many words as you want, sir.
So I set out a little bit of it, which is the credibility and capability in your forces. A number of folks in this audience will know what follows, which is the only thing more expensive than building a first-class air force is trying to build a second-class one. So you've got to invest in it. Back to credibility and capability. A strand from yesterday that I think we probably ought to pull out a bit more is there are a number of lines of effort here that need to be addressed concurrently. It's not a, do I buy this or do I buy that? Do I do R&D here or do I put the money into expenditure up front? The reality is you need to do all of those. And the bit which I was really pleased was discussed yesterday, but again, my word, we need to have a seminar on it, is risk in the air domain it's been a regressive discussion over the last 20 years. And we've got to understand and have that discussion better. So let me give you an example to kind of flesh out the theory of victory point. If I can buy an industrial printer that produces 15 Thunderbird 2s every hour, that I can now put different power plants, sensors, packages into, and then I put an air safety and airworthiness structure on it that applies to a multi-billion pound crewed aircraft. Is that right?
Well, hold that thought. And I know there's another question at the front. Robert Fox wanted to ask a question.
Sorry for Dame Angela, it's a bit of Groundhog Day. When I first met you, you talked about the quantum revolution, and which you've all been talking around. Could you give me a rain check where we are with quantum? And you feared from the first time we met, which was a future army demonstration on Salisbury Plain, you thought the Chinese, with quantum computing, were going to get way ahead of us quite significantly quickly. Now, I'm going to abuse the privilege of having the microphone. Can I do a pushback against the Air Marshal about media
Only
dialogue?
if it's good.
No, it's going to be bad news. Your brother's much... Oh, sorry. Your point about the media dialogue and the media discussion is absolutely found. I've been in this game now 57 years this September, and it's the changing context, and it's, you know, the society, but also the information environment in which we work. And I would like to say there are two heroes in this. My younger colleagues, and many of them are more than 2 decades younger than me, and they're represented here, are as good as any I have worked with in the DCA. They are good, and they are struggling with a much more complex media environment, editorial environment, proprietors, audience, TikTok, you name it, that I have. Also, the most eloquent spokespeople for what your endeavours are, and this is 50 years, are the service men and women I've worked alongside. They are the best to speak in your cause. And thank you for allowing me to say that.
No, Rob, can I?
Yes, yeah.
So first off, by the way, let's not get onto conscription. So first off, certainly not a pop at anybody in the media. And I'll tell you, I'll give you a personal example why. When I went out for a year as the Air Component Commander in the Middle East, late 16 to late 17, Mosul to Raqqa, we had done ourselves no favours with how we'd engage with people. I won't go into any more detail, but it wasn't as good as it should have been. And we can't critique people if we're not engaged in a discussion with them, for good or ill. And I wasn't allowed to have a Twitter account, but I was allowed to go and kill lots of people, which is a bit weird.
Well, I think certainly the reserve forces have helped with that. 7644 Squadron, I'd just give it a shout out. Media operations, we have certainly helped smooth the relations, I would say, over the past few years. But I do want to get back to this central point that Robert made. Can you tell us, Angela, where we are in terms of quantum right now, and how do you believe potential adversaries may be potentially ahead of the game?
No, I can't tell you that. What I can tell you is still no useful calculation from a quantum computer. So if I tell you, I mean, let's remember one thing today. When we talk about quantum technology, sometimes we're talking about quantum computing, and the answer is still quite a few quantum computers out there. I bought one, but still no useful calculation yet. Okay, you read fancy stuff about these great calculations they've done, but they weren't useful. And I'm not going to talk about what China's able to do. But quantum technology means many things much more beyond quantum computing. And there are all sorts of exciting, useful things. And I think particularly the dead reckoners. So, you know, the things you stick into a device, there's either going to be somewhere where it can't access PNT signals, or you're worried they might be jammed, and it can tell you where you are. And I mean, that's a real thing. So, I mean, we've all got used to quantum clocks, but the dead reckoners are here. So don't get confused that because the quantum computer still seems to be taking a very long time to arrive, that means all of quantum technology is slow. It's here, we will have it.
Mike, give me your take on quantum technology.
What she said. She's far more versed in that than I am.
Oh, can I have one more thing, actually? If you're interested in quantum technology, come to the Quantum Technology Showcase in London in the autumn. It's usually early November. It's like you go for the day, you come out and you think, oh my goodness, I've been in the future.
Fantastic. Great plug there. So Angela, as well, a question's come through. As the government's chief scientific advisor, what would you be advising the Prime Minister in terms of 3 priorities for defence and national security, and also in regards to what the MOD must do to embrace the present and future scientific and technological advancement?
Okay, so 3 defence things for the Prime Minister. Actually, I'm going to just start with defence. Defence, I'm really sorry, but could you please hire yourself a chief scientific advisor? That's really straightforward. You do not currently have one, and I think that's a bad place to be going into a strategic defence review, actually. I mean, your history is so rich in thoughtful, clever, useful science that gets pulled through into being in the hands of people who really have to use it. That it's really important that you don't lose that. 3 things for the Prime Minister. I would still say data, actually. I would still say data because the example you give, synthetic data is great if you know the rules. So if you know that's why synthetic data has been so fantastic for all the game playing. So basically, I mean, you might wonder, why did all those AI people build all those things to make games? And it's not just because they're it's not just because they're people who like playing games, although many of them are. It's because you know the rules. If you know the rules of the game, you can create data till you're blue in the face. And it will always be a correct representation of reality because reality is the game. The other time we can use synthetic data is when when it's not a game, but for some reason we know the rules very well, and Newtonian physics is the best example of that. So there are lots of places where synthetic data really is very, very useful, I agree. If we'd been a proper discussion, then I'm going to turn into one, I'd said to Mike, so that means you think you know how your adversary is going to behave, is that right?
Ooh, that's a great question. Well, you try to replicate what the human would do, right? But you also, nominal, off-nominal, and then we have randomizations. And so, and I'll give you a great example. Our company, way back when, years ago, did a competition called Alpha Dogfight, and we won. And the reason we won, yes, our agent was flying against different companies and eventually against a human in the sim, and we took it and flew with DARPA, with the Secretary of the Air Force. But the point was, the way that our agent won is that it played by different rules. And the rules they're there for everyone to exploit, but they weren't exploited because of a culture. So the humans and the other agents were built to conform to these training rules that we do when we fly. Well, this is in the sim, and there's no rules, and so our agents were trained without those rules, and so they were extremely aggressive. And a human would never do that because it has, reckless abandonment is what I would call it. It's just going to go. It has one job, which is kill. Like survive, don't care, I want to kill. And the way that the game was architected, it optimized for that. And as soon as you got the kill, the game would end. And so, even if he was going to be 90 degrees straight down and get a kill, and he was going to die 5 seconds later, it didn't matter. And so because of the way the game was orchestrated, it was optimized for that. So there's kind of 2 points of that. One of them is the artificiality of where the game starts and stops, and the other one is the constraints of the rules of the game.
So okay, I think for this audience, it is important to know that the reason, you have these unbelievable flight simulators, just fantastic, fantastic things. That's because Newtonian physics is a fantastic thing. We have no equivalent of Newtonian physics for human behavior.
We've, in the US, I'll tell you that the US is spending a lot of money, roughly $1 billion a year of building out a physics-based synthetic environment to do air and space training and test validation right now, because it's very, very important for the reasons that you say. That we begin to use low fidelity sims, we're going to use the wrong lessons and then take that airborne, it'd be detrimental. So, yeah.
Thank you. I'm just going to give the last word to Johnny, because we are going to have to wrap this up. There is so much more to say, I know, but Johnny, go ahead.
This is one of those hours where I really do feel like a humanities graduate. So,
Never mind.
I bear it heavily, and so I'll just offer one thought on that, but you could, hopefully it's a much broader one. Actually, you know what? You can work out how your opponent might operate and what they might do. And for this audience, it comes from the cockpit up to grand strategy in terms of understanding them. So leave you with a thought, and it might have been in Stephen Bunge's book from a few years ago, that the Luftwaffe knew which way most RAF pilots would brake in a dogfight. They'd brake left. If you think about it, anybody who's flown here, it's kind of easier to do that than it is to do that. So they lined up, the really sharp ones lined up their shot for which way the guys were going to brake. You can do that when you look at our adversaries and competitors at the grand strategic level, if you're curious enough, if you really mind the data, and if you put the time and the effort into it. My worry as air and space forces is we're very good at tactics and technology. We're very good at fighting the next 5 minutes every 5 minutes. Bit like Ferris Bueller, folks. You know, at times you need to stop and look around, because we need to be thinking about what our opponents, our adversaries, and our competitors are going to do, and we need to apply finite resources intelligently as we can to get ahead of them. And that requires thinking. It doesn't require expenditure.
Well, thank you very much. And it's a great thought to leave us with, really. Stop, think, and look around. And this is, of course, what this conference is all about. So thank you very much to the panel, to Mike, to Johnny, and to Angela. It's been absolutely fascinating. Thank you. Thank you.